Hello everybody, it's period 4, it's AP Physics 2, and you know what that means. Today we're going to learn the hardest, the most difficult, the most mind-boggling thing that we learned all year. The phases of matter. Okay, it's actually not that hard, but I bet you guys didn't remember that we have 2 extra phases of matter that we're going to go over today. Plasma and Bose. But first, we'll start with the 3 basics. First off is solid. In a solid, particles are so compressed together that they can barely move. That also means that it doesn't have a very high amount of kinetic energy. And the result of this, that means they do not conform to the shape of a container, which I have right here, a container of garlic salt and a measuring cup. You can see, whenever it's put into it, it does not take the form. The next phase of matter we're going to talk about is liquid. Liquids are basically the exact opposite of solids, meaning that the particles inside are more free to go around, which results in more kinetic energy and the ability to conform to the shape of a container. What I have here is like a container of water, and as you can see, it takes the shape of it. The last of the 3 basic phases of matter is gas. Gas particles are so far apart that they have a high amount of kinetic energy, which also means that they're unconfined or take up all of the empty space that's around. This also means that they do not have a definite shape, which means that if you put it in a measuring glass like I had, it just wouldn't feel it because it would be all around us. Now it's time for bonus matter, featuring plasma and Bose. First up, plasma. Plasma is not the most common state of matter here on Earth, but maybe the most common state of matter in the universe. Plasma consists of highly charged particles with extremely high kinetic energy. The noble gases helium, neon, argon, krypton, xenon, and radon are often used to make glowing signs by using electricity to ionize them to the plasma state. Stars are essentially superheated balls of plasma. Next up is Bose. Using a combination of lasers and magnets, scientists were able to cool down a sample of rubidium to within a few degrees of absolute zero. This led to the discovery of the new phase of matter, Bose. At this low temperature, molecule motion becomes very close to stopping altogether. Since there is no kinetic energy, the atoms begin to clump together, creating a superatom. Light appears to slow down as it passes through Bose, and Bose is most likely to be found in black holes. That's all I have to say about the phases of matter, so I guess this is the end.